Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 24 on our 2016 Grade 10 Cayley contest. What is the sum of all numbers q, which can be written in the form a over b, where a and b are both positive integers, and b is limited to be less than or equal to 10? And we've got an extra condition here for which there are exactly 19 integers between root q and q, and it's got to be strictly between them, and q can't be n or anything like that, although q could be an integer, I guess. B could be 1, for example. Okay, I'm just taking a quick gander at our answers. Everything's got a 0.5, so I'm guessing at least there's one situation where b is 2, something like that. Okay, so positive integers, and we need 19 integers n that satisfy root q less than n less than q. Okay. I mean, q could be an integer. Actually, root q could be an integer if q was something like 9. And then root q would be 3, although 9 and 3 are a little too close together. How close together can these things be? Because obviously I can't use, like, q is 100 and then root q is 10. There's got to be some sort of limit. So, well, okay, here's root q. It's got to be less than, so let's let the smallest integer be s plus 1, s plus 2. These should be less than signs. All the way up to, not s plus 19, but I guess s plus 18, and that also has to be less than q. And then those, if s is an integer, then all of these are integers. And I specifically want s plus 19 to be greater than or equal to q. Actually, let's renumber this a little nicer. Yeah, I can write this better. I specifically want s to be less than or equal to root q. Then s plus 1 is the smallest integer that's bigger than root q. And this will also make things a little easier to count, because now s plus 19 is the 19th integer in between the two. That's got to be less than q. It has to be less than or equal to s plus 20. Okay. So that needs to be true, I guess. But does that tell me anything? Maybe we can get some sort of relationship between s and q? It's got to be the, I mean, 19 is an odd number to be seeing, certainly. But what can we say? Well, in order to fit 19 things in there, the gap between q and root q has to be big, but not too big. So I guess maybe we should focus on these really close inequalities and play them off each other in some way. So the gap between q and root q in terms of size is q minus root q. We know q is the bigger one. They tell us that. Now, I know q has to be less than or equal to s plus 20. And I know root q is bigger, has to be at least as big as s. So subtracting off root q, subtracting off something that's even smaller would produce a bigger number here. So we can say something like this, and then like this. And that gets rid of the s's, actually. So the s's don't seem to matter. So the difference between q and root q has to be at most 20, maybe exactly 20. And that comes from the inequalities here. But we can also see that q is definitely bigger than s plus 19. And root q is definitely less than s plus 1. So subtracting off a bigger thing will be even smaller. So it's got to be strictly bigger than 18. Alright. I was about to write q minus root q has to be 19 or 20, but that's not necessarily true because q can be a fraction and root q doesn't even have to be rational. But, I mean, that's not a lot to go off of. So I need the q's that satisfy this. If q's satisfy this, do I necessarily get this this relationship with 19? Or is it possible I can still get 20 somehow? Alright, well, before we answer that, let's see what we can do here. So let's focus on the one side. 18 is less than q minus root q. If I bring the root q over to the other side and the 18 over to this side, I could square them. So 36q plus 324. And so q has to satisfy a parabola. So I've got a parabola over here. So this bit is a parabola. It'll have some roots, I assume. And so q needs to be anything where we're positive. Where this parabola is strictly above the x-axis. And I think we can get a similar parabola with this 20, and this one would have to be below or equal to the x-axis, I think. So I can do the q minus 20 over to this side and bring the root q over here and square both sides. So we'll get q squared minus 40q plus 400 has to be less than or equal to q. And then I can bring the q over to the other side. So q squared minus 41q plus 400 must be less than or equal to 0. And so that's another parabola. Probably shifted over a bit more, but I'm not entirely sure. And the q's need to be chosen in such a way that we are looking at below or equal to the x-axis. And so taking the two parabolas together, there might be only a certain group of overlap. Which I guess would be there, or, you know, it might be down here, I'm not entirely sure, but I would err on the side of greater q's. Okay. So I guess find the roots of these polynomials. So neither of them looks particularly nice. I'm going to try using the quadratic formula then. I'm just going to jump straight for it. I don't suspect I'm going to be able to factor. Maybe I will, maybe I won't, but when in doubt, quadratic formula always gives you a nice amount. It was 37,324. So 37 plus or minus square root of 37 squared. I don't know that off the top of my head, but I've got my calculator handy. So 1369 minus 4ac, so 4 times 324, so that'll be 1296. 12 to the power 4, all over 2. Yeah. So those are those two roots, and then the other two roots are going to be 41 plus or minus. 41 squared is 1681 minus 4 times 400. Oh, 81. That one will work out nice. Does this one work out nice? 73. No. But I'll get 41 plus or minus 9 over 2. So this one will be 25. So 25 or 18? 17? Oh, 41 minus 9. Let's 16. And this over here, root 73, is not nice. But, okay, grab a calculator. Root 73 plus 37 divided by 2. So we're looking at 22.772. I mean, that's probably fine in terms of decimal. And then both of them have to add up to 17, so I'll just, or not 17, 37, so I'll just subtract 37 and ignore the decimal place. So 14.2279, that's good enough. Okay, so in terms of that number line, these two roots that I want to be bigger than, so I got, say, 14.2 here, and I've got 22.7 in that one parabola. I just care about Q values that are bigger, or they give me something above the x-axis. And so for this one over here, we've got 25 will be somewhere up here, 16 will be somewhere up here, and we want values of Q, so the parabola is below, so we want things in between. So the only overlap is Q's that are greater than 37 plus root 73 over 2 and less than or equal to 25. So that should work. Will all of them actually end up giving us nice numbers? I'm not entirely sure. But I know I don't want to include that root, but I can include 25. And so this is about 22-ish. Actually, it's you know, about 22 3/4. Okay. So I have a range of values of Q. Now the question becomes, does every Q in here work? Every Q in here should satisfy this equation down here. But that does that automatically imply that there are exactly 19 things in between? Let's break it down in terms of integers. So this guy, you know, call him 22.7. Doesn't really matter. But we could break this down into the Q's that are between this and the next integer. Right? So we could look at Q's that are between 22.7 and 23. Do I want to include 23 or not? Yeah, if I include 23, then we're good. You know, I guess we could weaken this to even just greater than 22, but doesn't really matter. We can even leave him as is. Because the greatest integer less than Q at that point will be 22, and root Q is not going to be an integer. Root Q is going to be above 4, but less than 5. So the integers between root Q and Q, 5, 6, 7, all the way up to 22. How many of those are there? Well, 22 minus 5 plus 1, there's 18 of them. Well, hold on, I thought we chose this so that 18 wouldn't happen. Did we screw up? Maybe you just can't have Q's that low, because if I bump Q up to be more than 23, but say less than 24, because that's still in our range, we can go all the way up to 25, the root Q will still be less than 5, but now the biggest thing that's less than Q is 23. And how many numbers are in that range? Well, now it's 19, so okay, that works out. So Q's that are greater than 23, less than 24, will have 19 integers in the range that they want. Okay, how about things that are greater than 24, less than or equal to 25? Well, so the biggest thing less than Q is going to be 24, but now root Q is not guaranteed to be less than 5. I think we need another case. If I say Q is less than 25, root Q will be less than 5. But now we've got one too many things because we've got one more number. So it'll be 20. But now if q is equal to 25, finally root q is equal to 5. So the next smallest integer is 6. And so that sort of eliminates the new number that we've gained, and we're back to 19. So q can be 25, or it can be bigger than 23, less than or equal to 24. And this will all work out. Okay, and then now we have to deal with the fractional values of q. What fractions are in this range? Okay, well, I suppose we could classify them based on the b value. So we've already got 25, so what q... So we're just looking at q's that are greater than 23, less than or equal to 24. So if b is 1, q's got to be an integer, so q is 24. If b is 2, you could have q is 23.5, so 23.5, or 24, but we already counted 24 once, and we're going to have to be careful that we don't double count. So in terms of thirds, and it might be easier for me to write fractions, we'll have 23 and a third, 23 and 2/3. You won't have 23 and 3/3. It's 24. We already counted it. For the quarters, you can have 23 and a quarter. We're not going to have 23 and a half. We already did that. 23 and 3/4. For fifths, you'll have 23 and a fifth, 2/5, 3/5, and 4/5. And actually, all of these look like 23 plus something. So I think it might be easier just to write out. We'll count how many 23s we've got, and then we'll add up the various fractions. So this is 23 plus 1. This is 23 plus a half, 23 plus a third, and plus 2/3. 23 plus a quarter, and plus 3/4. For a fifth, it's 23 plus a fifth, plus 2/5, 3/5, and 4/5. And so far I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 23. For 6, you'll have 1/6, not 2/6, because that would be a third already. Not 3/6, not 4/6, but 5/6. For 7, we should get everything. Except, of course, for 7/7. I suppose we could try and cram in 8 up here. 1/8, not 2/8, because that's the same as a quarter, but 3/8, 5/8, and 7/8. For 9, we can go 1/9, 2/9, but 3/9 would be a third. 4/9, 5/9, 7/9, 8/9. And the last fraction that we could have is 10. 1/10, not 2/10, because that's already a fifth, but 3/10. 4/10 is out, 5/10, 6, 7/10, not 8/10, because that's 4/5, but 9/10. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there's the 25 that you can have. We're going to have 32 23 plus somethings. So it'll be plus a 1, plus a 1/2. And then the 1/3 and the 2/3 will turn into another plus 1. The 1/4 and 3/4 turns into another plus 1. So this might be where that 1/2 comes from. 1/5 and 4/5 pair up. 2/5 and 3/5 pair up. In fact, everything's going to pair up. So we'll get 2 here, 1 from here, 3 from here, 2 from here, 3 from 9, and 2 from 10. So where were we? So 2, 1, 3 from the 7, 2 from the 8, 3 from the 9, and 2 from the 10. All right, and let's get to calculating. Does this work out? Does this give me something good? So 32 times 23 is 736 plus 25, so this should be 761 and a half. And then 1 and 1 and 1 and 2 and 1 and 3 and 2 and 3 and 2. So plus 16. So that should be 777 and a half, or 777.5, I think is the way they presented their answers. Is that an option? It's staring at us right in the face. It's C, and that's what I'm going to go with. All right. Not a bad question. A little long for my tastes. The octagon one just before was also a little long, but that's okay. I mean, you got to put in a little bit of effort when you're doing your Part C questions. Up next, we've got just our final question, question number 25. I will see you for that in the following video.